Atterperg Limits, named after the Swedish soil scientist A. Atterperg, are water content values at which notable changes in soil behavior occur. This test helps to determine the liquid limit and plastic limit of soils. Liquid limit. The liquid limit of a soil is that water content at which the soil passes from a plastic to a liquid state. At liquid limit, the clay is practically a liquid but possesses a small shearing strength. Plastic limit. The transition of the soil from the plastic state to the solid state is called the plastic limit. The soil in the plastic state can be molded into various shapes. As the water content is reduced, the plasticity of the soil decreases. Ultimately, the soil passes from the plastic state to the semi-solid state. When it stops behaving as plastic, it cracks when molded. The water content at which the soil becomes semi-solid is known as plastic limit. The water content corresponding to an arbitrary limit between the plastic and the semi-solid state of consistency of a soil. Water content at which a soil will just begin to crumble when rolled into a thread approximately 1/8 inches in diameter. Procedure. The liquid limit can be obtained by two methods, namely Casa Grande apparatus, cone penetrometer apparatus. Casa Grande apparatus. About 120 grams of dry pulverized soil sample passing 425 micron IS sieve is weighed and mixed thoroughly with distilled water in the evaporating dish to form a uniform thick paste. A portion of the paste is placed in the cup above the lowest spot and squeezed down with the spatula to have a horizontal surface. The specimen is trimmed by firm strokes of spatula in such a way that the maximum depth of soil sample in the cup is 10 mm. The soil in the cup is divided along the diameter through the center line of the cam, followed by firm strokes of the grooving tool so as to get a clean, sharp groove. The crank is rotated at the rate of 2 revolutions per second, either by hand operated so that the cup is lifted and dropped. This is continued till the two halves of the soil cake come into contact at the bottom of the groove along a distance of about 10 mm. A representative soil is taken, placed in the moisture container, lid placed over it and weighed. The operations are repeated for at least 4 trials with slightly increased moisture content each time, noting the number of blows so that there are at least 4 uniformly distributed readings of number of blows between 15 and 35 blows. The container is dried in oven and dry weight determined the next day for finding the moisture content of the soil. This brings us to the end of the step-by-step process of conducting the liquid limit test by Casa Grande apparatus. Now, let us take a look at the process of finding liquid limit by cone penetrometer apparatus. About 150 grams of soil sample, thoroughly mixed portion of the soil passing 425 micron IS sieve is worked well into a paste with addition of distilled water. The wet soil paste is then transferred to the cylindrical cup of cone penetrometer apparatus. It is ensured that no air is trapped in this process. Finally, the wet soil is leveled up to the top of the cup and placed on the base of the cone penetrometer apparatus. The penetrometer shall be so adjusted that the cone point just touches the surface of the soil paste in the cup, clamped in this position. The initial reading is either adjusted to 0 or noted down as is shown on the graduated scale. The vertical clamp is then released, allowing the cone to penetrate into the soil paste under its own weight. The penetration of the cone after 5 seconds shall be noted to the nearest millimeter. If the difference in penetration lies between 14 and 28 mm, the test is repeated with suitable adjustments to moisture, either by addition of more water or exposure of the spread paste on a glass plate for reduction in moisture content. The test shall then be repeated at least to have 4 sets of values of penetration in the range of 14 to 28 mm. After this, a representative soil is taken, placed in the moisture container, lid placed over it and weighed. The container is dried in oven and the dry weight is determined the next day for finding the moisture content of the soil. This brings us to the end of the step-by-step process for conducting the liquid limit test by cone penetrometer apparatus. Now, let us take a look at the step-by-step process of finding the plastic limit. Procedure: about 20 grams of dry, pulverized soil passing 425 micron IS sieve is weighed out. The soil is mixed thoroughly with distilled water in the evaporating dish till the soil paste is plastic enough to be easily molded with fingers. A small ball is formed with the fingers and this is rolled between the fingers and the ground glass plate to a thread. The pressure just sufficient to roll into a thread of uniform diameter should be used. The rate of rolling should be between 80 and 90 strokes per minute, counting a stroke as one complete motion of hand forward and back to the starting position again. The rolling is done till the diameter of the thread is 3 mm. This process of alternate rolling and kneading is continued until the thread crumbles under pressure required for rolling and the soil can no longer be rolled into a thread. By trial, the thread which starts crumbling at 3 mm diameter under normal rolling should be obtained and this should be immediately transferred to the moisture container. Lid placed and weighed to find the wet weight of the thread. The container is kept in the oven for about a day and dry weight found to determine the moisture content of the thread. The above process is repeated to get at least 2 consistent values of the plastic limit. Plasticity index is equal to liquid limit minus plastic limit. Application: the test for Atterperg's limit is carried out on embankment, subgrade, GSB and WMM. The acceptance criteria for the different layers are: embankment, Atterperg's limits, liquid limit, max 70%, plasticity index, max 45%, subgrade, Atterperg's limits, liquid limit, max 70%, plasticity index, max 45%, GSB, Atterperg's limits, liquid limit, max 25%, plasticity index, max 6%, WMM, Atterperg's limits, liquid limit, max 25%, plasticity index, max 6%. This brings us to the end of the step-by-step process of finding the Atterperg's limit.